Okay, so another quick little mini lesson on the quadratic formula so you have hopefully a little bit better understanding of how the quadratic formula works in terms of solving quadratic equations. So I've typed out some stuff here for you on this slide. You can see that we use the quadratic formula to solve quadratic equations. And those are equations where the highest power on a variable is going to be a 2. I gave you the general form. We've talked about this in class, the ax squared plus bx plus c equals 0. In order to use the quadratic formula, you have to be sure of two things. One, your equation always has to equal 0. And if you can identify the values of a, b, and c, those coefficients and the constant, it will make your life so much easier. So our quadratic formula, if you haven't written it down already, is this. X equals negative b, that's a b, plus or minus the square root of b squared minus 4ac all divided by 2a. So again, those values of a, b, and c, the coefficients and the constant from your equation, are going to help you figure out what the value of x is that makes your equation work. So here's an example of what we're talking about. If I have the quadratic equation 3x squared plus 2x minus 4 equals 0. So my equation is equal to 0. That's good. So I know my value of a is 3. My value of b is 2. My constant is negative 4. So I can start to use my quadratic formula. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 4 divided by 2 times 3. Once you have substituted all your values in, just begin to simplify. Follow your order of operations. So nothing's happening outside yet. Square root 2 squared is 4. Our minus sign here and our negative here are going to turn into a plus. So 4 times 3 times 4, that's going to be 48. All divided by 6. Alright, so as we continue to simplify here, we get negative 2 plus or minus the square root of 52 all over 6, which means we really have two answers. Negative 2 plus the square root of 52 over 6, and negative 2 minus the square root of 52 divided by 6. So at that point, I probably want to use my calculator. Since I've got the square root of 52, that's not a perfect square. My answers are both going to be decimals. You'll find out later, or I can tell you right now. If we left it like that with the square root, that's fine. That answer works out just okay the way it is. But if we needed some other information, we'll probably use our calculator and actually calculate what the decimal is for each of those two fractions. All right, so another quick example here to help you out. What if our equation is not set equal to 0? What if I've got, let's have something that works out here. Let's say I've got x squared plus 7x equals negative 12. Okay, our equation is not set equal to 0. We need it to be set equal to 0, so that's what we need to do first. Add 12 to each side. And now have it so that your equation is set equal to 0. Now you can determine your three values and use your quadratic formula. Okay, so you substitute your values in, And now simplify. 7 squared, we get 49, minus 48, all over 2. And so we get negative 7 plus or minus the square root of 1. Well, we know what the square root of 1 is. It's 1. So you've got two answers. Answer number 1, negative 7 plus 1 over 2. Answer number 2, negative 7 minus 1 over 2. And so when I solve those, I get negative 3 and negative 4. So I know that x equals negative 3 and negative 4. And that's it. So that's how you use the quadratic formula to solve quadratic equations, whether your equation's already set equal to 0, or as in this case, not set equal to 0. You've seen what happens when you can take the square root, and when you can't take the square root. If you have questions, go back and look at stuff again. If you have more questions after that, be sure to ask me in class. We'll see you then. Bye-bye.